Hello everyone, let's look at this integral today. This integral is fun because by just first looking at it, it doesn't seem like we can do anything that can find the answer immediately. Okay, so that means we need to do some work. First, we look at the e to the 2x. And e to the 2x, we can actually write it as what? We can write it as e to the x and then quantity square. So there is a square. And then we can also write 1 as 1 square. So we have the sum of 2 squares. So first, it really just looks like we can do tricks up, but we actually don't know yet until we get there. So let's actually try it. So we can do a use up first. So that means we are going to let u be this thing. Okay, so we can start. So we can write the integral, and then we are going to just put it as e to the x square, and then 1 square, and then there was a dx. And then now let's do a use up. So we are going to let u be e to the x. So du is going to be e to the x dx. And then we can solve for dx because we're going to make the substitution over here. So that means we got to divide both sides by e to the x. So we have 1 over e to the x du. And then we are going to get dx over here. And so now we are ready to make the substitution into this integral. So here we are going to get the square root, and then now that turns into the u, right? So we are going to get quantity square. Well, actually, we don't need the parentheses. So we are going to get u, and then we have square plus 1 square. dx becomes 1 over e to the x. And it just happens that e to the x is u, right? So we can write 1 over u. So we write 1 over u over here and then du. So now this is the integral with just u in it. Okay, so now we can simplify it. And then we are going to get the square root of, actually not simplify, just rewriting so that it looks different, right? So we have the u here and then we have the du here. At this point, it looks like we can do a trick sub here, but if you want to avoid doing the trick sub, then we can make another u sub over here, which will allow us to avoid doing the trick sub. So let's try that. Okay, so we are going to, I'm just going to use a different letter now. So we use w, and then we are going to let w be the whole radical over here. So we are going to get u squared plus 1 to the 1/2. Okay, and then dw is equal to, bring down the 1/2, take the derivative, so u squared, the inner function doesn't change, and then now we subtract 1 from here, so we get either 1 over 2, and then due to the chain rule, we need to multiply by the derivative of the inside, so we're going to get 2u, and then du. Okay, as you can see here, the 2 and the 1/2 will get cancelled, and so we can solve for du again, so move everything to the other side. So we are going to get this has a negative 1/2. So if you move it to the other side, it becomes positive because this is already in the denominator. So if you just look at this expression over here, dw is actually equal to what? U over. U is at the top and this is at the bottom. So we get the u squared plus 1 and du. So you can see that if I get all this stuff to this side, I need to multiply by the reciprocal of this. So that means we're flipping this fraction. So we have square root of u squared plus 1 over u. And then dw equals du. Okay, so that looks like it's a lot of stuff, but it will be okay. So now let's make another substitution in this integral. So continue. This is there. And we can actually turn it into w, right? So we are going to just get w here, for coming from here. And then what do we get? We don't have an expression for u yet, right? So we are just going to leave it for now. And then times. Now the du is going to be replaced by this expression. So let's just put it there. It just happens that w is equal to this radical u squared plus 1, right? So you can change it to w. So we have another w, and then there was the u at the bottom, and then dw. Okay, so this integral actually now becomes what? W squared over u squared, and then dw. And then now we cannot continue with the integration yet because there was still a u here, but our integral we're integrating with respect to w. So we still got to find an expression. for this u square in terms of w. So we can do it from here because we have a u square here. So all we need to do is to isolate the u square, and then we can get an expression for this u square. So now coming down here with the calculation, so let me use a different color over here. So we can square both sides. So we are going to get w squared is equal to, you square here and then you square the square root so that they cancel out. So you're just going to get u squared plus 1. Now we just need to isolate the u squared. So that means we are going to get what? W squared minus 1 is equal to u squared. Okay, so now we can replace this u squared by w squared minus 1. So let's continue. So w squared over, and then u squared turns into w squared minus 1. So we are going to get w squared minus 1. And then dw. So now this integral actually becomes smaller. I mean, it becomes simpler, not smaller. So what should we do with this one? We can actually either do long division because now they have the same power, or we can actually use a trick that looks like this. So we have w squared. We can minus 1 first. We can subtract 1. So let's do that. So we can subtract the 1. And then if we are subtracting the 1, we're changing the problem. So we need to add the 1 back. And then I will explain why we are doing this in a minute. So w squared minus 1 and then dw. So this, actually we can break it because there are multiple terms in the numerator. So we can actually break it as w squared minus 1 over w squared minus 1. Okay, we're actually grouping those together. And then now plus coming from here. And then we are grouping those together. So we are going to get 1 over w squared minus 1 and then dw. I'm missing a dw over here, so let's just put it back. And then now you can see that this actually just turns into 1, right? As you can see. So this one is easy to integrate. We just need to worry about this one for now. Okay, and then you may say, what should we do? This is a rational function, and then it has a square here, so we can do partial fraction on this function over here. So let's just do that quickly on the side. Okay, so we can have 1 over w squared minus 1, and then we can factor the denominator first, which will give us 1 over w plus 1, and then w minus 1. And then that's equal to, now we can write down the form of the decomposition, which will be a over w plus 1 and then plus b over w minus 1. So the LCD is this denominator over here. So if we multiply that by both sides by that LCD, so we are going to get 1, just the 1 at the top, and then we multiply by this LCD, then we are going to cancel with the w plus 1. So we are left with a times w minus 1, and then plus b, and then times w plus 1, because the w minus 1 will get cancelled, so we get w plus 1. And then we can actually figure out the a and b really quickly by just we can just let w be 1. Then we are going to get 1 from the equation. We get, if we plug the 1 in here, this becomes 0, so we are left with just the b, right? So we have b times 1 plus 1. So 1 plus 1, and then we get 1/2 b. No, actually it's b times 2, right? So 2b. And so that means b is equal to 1/2. Okay? And then we can let w be -1. And then when we let w be -1, so we still have the 1 on the left side, and then this -1 plus 1 will actually make this term go away. So we are left with just the term with the a. So we have a times, what is that? -1, so -1 minus 1. So we are going to get -2a. So a is equal to -1/2. So we can actually rewrite this one as the integral, okay? A over w plus 1. A is -1/2, so -1/2 over, what is that? W plus 1. And then plus the integral of b. B is 1/2 over w minus 1. So we get w minus 1 and then dw. Okay, so just continue with the calculation. So we are going to get, this is 1, right? So we still have the 1 over here. So let's just leave it for now. And then I'm just going to simplify those first. So minus 1/2 integral of 1 over w plus 1 dw. And then plus 1/2. And then the integral of 1 over w minus 1. Okay, so now we can do the integration. So integrating with respect to integrating with respect to w. So we are going to get w and then minus, what about this? This is 1/2 and then ln of absolute value of w plus 1 and then plus 1/2 and then ln of absolute value of w minus 1. Okay, and then plus some constant c. And then now what really happens over here is that we are going to switch back to the original variable. What is w equal to? Go back here. W is equal to this thing. It's over here. So that's u squared plus 1 to the 1/2. That's actually the square root of u squared plus 1, right? Let's switch back to that. So we are going to, let's actually just write it down. So w is equal to square root of u squared plus 1. Okay, so we are going to just make those substitutions. So w becomes what? Square root of u squared plus 1. And then minus 1 over 2 ln of this one. So square root of u squared plus 1. And then plus 1. There's another plus 1 over here. And then plus 1 over 2 ln of absolute value of the square root of u squared plus 1. And then minus 1. Okay. But that's still not finished because we make another u sub, right? So there was a u is also not the original variable. So we still got to convert it back to the original one, which is x. So u is equal to e to the x. Okay, so let's just write it. U is equal to e to the x. And now continue to just keep making the substitution back. So we are going to get u squared. So square the e to the x. We are going to get e to the x. And then square. And then plus 1. Then minus 1 over 2. ln of absolute value of the square root of, again, is e to the x. And then square plus 1, and then plus 1, and then just keep going, right? This is really just a simple substitution. Okay, and actually if you want to simplify it, then it becomes just e to the 2x plus 1, and then the rest is really just simplify the same way. So e to the 2x plus 1, just keep writing it. I'm just going to write faster. Okay, so that's it for this problem. And if you like this video, please give me a like and then also subscribe to my channel. And I will see you next time.